In number 25, they ask you to write an equation that represents the height of the planet on the nth day. Now, on this table, the first row is technically your x, and this row is technically your y. So what I recommend when you want to write an equation is I'm going to pair these values up as points. I'm going to do 1 and 3.0 as a point, and I'm going to do 2, 4, 5, or excuse me, 4.5 as a point. So to write an equation of a line, what we want to do is we want to find the slope of these points first. So I'm going to do change of y divided by change of x. So what that means is I'm going to do 4.5 minus 3.0 and then 2 minus 1. I get 1.5 over 1. I get 1.5. So my slope is 1.5. Now what I want to do is plug the slope, which is 1.5, and one of these 2 points, doesn't matter which one, into the point slope formula. This is my point slope formula. So I'm going to plug in y, and then let's just pick this one. My y value is 3, so I'll plug in 3. My slope is 1.5. My x value is 1. Okay, then I distribute. Solve for y. Now the only problem with this is it says write an equation to represent h of n. So if you wrote your answer like this, you would get credit, but you wouldn't get full credit. Your answer needs to be h of n equals 1.5 n plus 1.5. This would give you full credit. Now there are many ways to do this problem, but this is the way that I chose to do it. Number 26 asks you to graph the inequality. 2x plus y is greater than 1. Notice this is not in standard form. Now, if you've noticed on this exam, this is what they're going to do to you a lot. They're going to give you an inequality or an equation that's not in standard form. So what I have to do is subtract 2x from both sides. And I get y is greater than negative 2x plus 1. Starting at positive 1, I know my slope is negative 2, so I'm going down 2 over 1, down 2 over 1, down 2 over 1. Okay, up 2 over 1, up 2 over 1 to go backwards. Because of this symbol, I know I'm going to be using a dashed line. Hopefully you use a ruler unlike me. Y is greater than, so that means I'm going to shade above this line. So the graph of this inequality would look like that. Be sure to put your arrows at the ends of your line. Number 27 asks you, gives you a set of data for a petri dish bacteria growth. Rachel wants to model this information with a linear function. Mark says exponential function. Which model is the better choice? If you notice, the number of hours is all going up by 1, so that's pretty consistent. But if you notice, the difference between all these is growing it's not growing at a constant rate. So what we say is we're going to pick the exponential growth because this graph doesn't grow at a constant rate. If it was growing at a constant rate, then the difference between all of these would be one of the same number. It's exponential because it's growing at a changed rate. This one is 170, and so on and so forth. Number 28, a driver leaves home for a business trip. She drives at a constant speed for 60 miles per hour. Okay, so 60 miles per hour. So that means that after 1 hour, she would have gone 60 miles. After 2 hours, she would have been at 120 miles. She spends 30 minutes changing her tire. So if this represents 1 hour, then this is a half hour. Her distance did not change. She resumes driving and drives at 30 miles per hour. So from 2.5 to 3.5, she went up 30 miles. 30 miles would be this hash mark, so she actually goes up to 150. Okay, for the remaining 1 hour, so we're going to connect from the origin all the way up to this point, over, and we will stop like such.